So now we begin my absolute favorite part of the course, the effects. Okay, this is, probably the first lecture that I ended up digitizing in this PowerPoint format, and it's definitely my favorite, and I will be bringing in as many examples of effects as I can. So hands out, I've got the copy of this lecture, which may still change. I'm hoping to include some stuff on pitch shifting before next week, but I don't know if I'll get to it, so that's a potential. The other thing is I printed out some online articles. There's two companion articles, Technology to Fuzz Face and Technology to Tube Screamer. And those are pretty interesting because they go through a really detailed analysis of the two very popular circuits, including looking at some of the symmetrical and asymmetrical properties. So I encourage you to look at that. There's some stuff from Harmony Central, which is really good. And then the last one is a copy of a few select pages from a Craig Anderton book. If you see anything by Craig Anderton, it's probably worth reading. He's actually, in kind of an ironic twist between, these are the references I've been using since I started this class 10 years ago. And Harmony Central always had these series of articles on the different types of effects, and they're very good. Craig Anderton had books on effects. His two big name books were this one, which is Guitar Gadgets, and the other one was Electronic Projects for Musicians. Both great books. He's since kind of moved on to other things, but he's encouraged thousands of people. And the ironic thing is now he was hired by Harmony Central. When musicians friend bought Harmony Central, they added a bunch of famous names. And so Craig Anderton runs certain forums and writes articles for them. And he's not doing the effect stuff as much, but there was like a giant thank you Craig thread where everybody who was influenced by his books could thank him personally. It was kind of nice. And so his books are pretty good. So this kind of describes different effects. And these are just a couple quick clips. I think this book might be out of print by now. But it's some interesting supplemental reading. He also did a book on, or he did a series of columns, and there's a book published that was a compendium of that. And that's just some of the tone control stuff we talked about. All right, so we're going to talk about effects. Like I said, these are my favorite things. Most of the time we talk about effects, we talk about the little stomp boxes, and that's usually what I'm referring to when I talk about most effects. Of course, you do have rack mount effects, and nowadays you have purely digital software-based effects. And then you get into interesting things that are like software-controlled stomp boxes. So like there's a device that, if I remember, I'll bring in next week called the Magic Stomp, which is Yamaha's effects processor. And what they did was they had a big floorboard thing that had like 10 knobs. And they took the digital guts of that, and that was called like either the AG stomp or the UD stomp or the DG stomp. They had a bunch of these different ones with lots of knobs you could keep. And they compressed it into a small thing with 3 knobs, but made it all programmable. And then it had a USB interface, and you can control it all from your laptop. So you plug into this USB device, and you get dozens of virtual knobs you could control that control this little pedal, and it's pretty neat. But by and large, we're going to talk about simpler ones. And I like to break things down into 3 basic categories. And not everything fits in these, but these are 3 good categories to start with. So the first thing is amplitude based. And there are different varieties even within that. The idea is that it affects the volume, it affects the gain. You have certain things like a passive volume pedal, right, which goes from unity gain at full up to 0 at full down, and somewhere in between. So that takes your gain and can reduce it. And then you've got a compressor which changes your gain dynamically, but again, it's trying to keep it clean. And then you've got distortion, which is again a amplitude-based device, but with distortion, you're trying to modify the signal in the time domain, if you will. You're just saturating your clipping when you're doing something. Another clean device tremble. Filter-based, on the other hand, I haven't brought examples of filter-based devices. We're going to talk about those next week. But that's when you get to your wah-wah pedal, your equalizers, phase shifter. These are basically analog devices that are working in the frequency domain, if you will. And then we get to time. When I say time-based here, I'm distinguishing from the amplitude-based. Again, we understand them by looking at what they do in the time domain, but they're usually analog. When I talk about time-based, we talk about delay, basically. And there's the simple to understand digital delay, and then there are other variations of delay that came before digital delay became practical. We'll talk a little bit about those. All right, so I want to talk a little bit about the background topics that goes into before I discuss any of the actual effects. I want to talk about how it's been discussed. So we've got time response and time delay. Basically we know what that is. Frequency response. You know the difference between a Bode plot and a magnitude phase plot? Kind of the key difference I think gets lost nowadays. What's a Bode plot? That's the key distinction I'm looking for. The Bode plot is the hand-drawn lines. What happens? You're 20 dB per decade, you're flat, you're minus 20 dB per decade, you've got some error at the curve, whereas the mag phase plot is evaluated at each frequency, what do you get at? And the key thing to do is, as engineers, again, you want to be able to look at a circuit and be able to do that Bode plot by hand. You'll be able to analyze it, and then you also want to be able to use the computer thing, because the hardest thing to know is when the computer is doing the right thing, or when it's not doing the right thing. So that's why it's critical to still look at a Bode plot as well as a mag phase. Yeah.
Do you happen to know there's a MATLAB command which is Bode? Does that use like the Bode plot rules for drawing it, or is it just a magnitude phase?
It's a mag phase.
All right, because I couldn't find any magnitude phase.
When you get to MATLAB, there are actually a few different variations. There's Bode, which does mag phase. There's FreeCast, which does mag phase for a polynomial. And then there's also, in the control systems toolbox, I don't remember if there's one or two functions that do gain margin and phase margin. You use those for stability in control systems. So it does the Bode plot and then labels the margins. It does the mag phase plot, labels the margin. Yeah, no, I haven't seen anything that does an actual Bode. I don't remember if that used to be a circuits assignment or if I used to assign, I might have assigned that to MATLAB. I think I assigned that as a MATLAB project at one point. So, use the line command and do a Bode plot. And there are a couple different ways of doing Bode. I don't know which way you guys have learned it. If you do this one where you draw all the lines simultaneously and then you figure out which segments apply at which time. There's that method, and there's another method where you kind of go, you draw out where all the break frequencies are, and then you kind of go along and then determine. That's the method I prefer, and that wasn't the common method. That was the way Professor Costello taught it in control. That felt a lot clearer. So that's good, because you want to get a good understanding of that, because most of this musical stuff, frequency response is key. So you need to be able to look at your tube circuits, your effects, how everything. You need to be able to, okay, that's what that looks like. Most of it's single order, high pass, low pass things, but you very often get second order things. You want to be able to visualize that. Okay. Now that's all largely I'm talking analog domain, but everything applies to digital domain too, right? If you've got a transfer function in terms of S, you can use FreeCast and MATLAB to apply it. You can do your Bode plot. If you've got it digital, you can use FreeZ. It's the same stuff from DSP. I haven't gotten too far into the analysis. I assume you know that stuff. I'm going to use that to show you results here, and then you're going to use building blocks to build your own effects. And by building your own effects, unfortunately, I just mean in MATLAB, programming your own effects. Makes it a little easier, but not the fun of being able to plug in any time. Okay, spectrogram. Have you seen spectrograms before? Okay. Time